I'm going to talk on, this talk's called The Hunter Games. I actually don't have any like Hunger Games pictures or puns, just the title. But yeah, I just want to share some strategy that I've used before for finding an adversary. So whether that's like red team or nation state, or really like anyone you don't want in your network. Just some strategies that I've used to find them, and also some very like specific analytics you could write. Let me introduce myself. I'm Ross Wolf. I'm a researcher at Endgame. You might have seen the booth over to the side, but we're an endpoint security company. So I end up working a lot on anything related to events. So events being like Windows, logs, Sysmon. We don't use Sysmon, but you could swap it out conceptually. So anything that you capture that has like a timestamp, that's an event. So I work on a couple of frameworks around there, mostly our event query language, which I'll get into some more, and I have some past experience. Before Endgame, I was at MITRE, where I did some red teaming, blue teaming, and contributed to attack. So I'm going to use some of those lessons that I've learned, and hopefully can share and impart some of that. What's this in email? Bad Wolf report. Are we compromised? Bad Wolf is a Russia-based. Never mind. We'll get back to that later. An update? Another one? Okay, more update. What is this? Let's look. This is semi-made up. It's actually Bad Rabbit, but I swapped it out with Bad Wolf. Also Space Force. You can sort of get it. But anyway, so yeah, one example, like, let's say you get a threat report that comes in, like, and you get like a boss or someone else asking, do we detect this? Do we have any visibility to this? And if we didn't get, if we aren't compromised, how would we know if we were? And those are like very realistic questions that we have. And that's often okay, great, new report, now what? What do we do about it? So I want to kind of talk about how we can go from something like this into something much more tangible, and to be able to reply back with hopefully like a concrete answer, like, oh, we have these detections in place, and I've got some degree of confidence that even for threats that we don't know, we can reason about what we would see. So in the talk, I want to go through a bit of that threat model in general. So we're going to use MITRE's attack framework to organize adversary behavior. And then I'm going to go through event query language, which we developed at Endgame and released end of last year. So if you want to like play with any of these examples on your own data sets or something that we provide, you're totally free and encouraged to do that. And then after going through a threat model, what our data looks like in EQL, I want to go through generic techniques that any threat actor would use and how we could turn those into detections each step of the way. And then talk about, once we go from specific techniques that an adversary would use, how can we have an approach for looking for things that we don't even know? Because there's still these general principles and concepts that they'll use. So what are those, and how could we understand what's weird for my environment? And then the last thing we'll cover is just some steps that you can take if you want to contribute any of your logic back, or look at some of the things that we've contributed. We're trying to just build InfoSec. We're just trying to build a community. So yeah, hopefully we can all share and kind of grow together. So what is this concept of threat-based detection? By that I mean, like, you have a threat, some model. How do you orient your entire process around turning that from like some APT, some threat, some report that's like high level and talks about things, into more concrete like alerts? Because that's like what's tangible and we can really grab onto. So in general, the process, and this is based off of some of my past life work at MITRE. This paper was essentially what drove a lot of the cyber analytics repository. So a lot of this stuff is going to be similar to that. So the first thing is to understand what your threat actually looks like. And one thing here I want to kind of stress throughout the talk is that as important as like indicators are, they're not threat hunting. They're just like different problems there. Like if you're trying to be more proactive, you can't predict a hash that you've never seen before. And so it's just a different technique, different problem. So I'm scoping this more to behaviors than specific tools or indicators. I also want to explore, the mind of what an attacker, how they think. So since I have some like red and blue experience, I want to share like how I kind of thought red, and then what the blue parts along the way are that we can meet that. And then in order to be able to detect anything, you have to see, like, is my data any good for the type of threat I have? If someone's like only targeting switches and never hitting an endpoint, and all you have is endpoint data, you probably have the wrong thing. But if you expect that a lot of your crown jewels are on endpoints, but you have no visibility into that, that's potentially a problem. So understanding like where those lines are. And also having familiarity with your platform. Like if you're using something like Elasticsearch, like you're going to be easy with queries that are more atomic, look for certain events, do some simple stats, but like you start doing something really stateful and you just kind of like run out of options. You have to like roll your own thing on top of that. And then the final thing is developing all of that into this process of testing out and creating, refining analytics. There's several frameworks out there for basically having like tiny little adversary in a box. Run this script that does one behavior kind of out of context. Do you have something in place for that? So Red Canaries released Atomic Red Team. We released like Red Team Automation. MITRE's got a thing called Caldera that tries to chain multiple techniques together. But there's so many frameworks there, so if you do want to test, there's plenty to get started. But at the same time, it's still really useful to look for real hands-on people doing a red team, because as great as like those scripts are, it's a lot of the times an adversary is going to find your easiest weakness to get there. And like if there's a passwords.txt file, I don't have to run Mimikatz and like dump credentials. It's like, oh, cool, here's a shortcut. So having like an actual human run on a red team in your environment, so that you can continue doing that process of improving even your own mitigations or group policy or whatever you have in place. And finally, one thing is like being okay to admit that you're wrong, and some ideas are bad ideas. I thought I was good with ideas. I'm also really good at bad ideas. So sometimes like I'll be like, oh, this detection would never false positive. I know Windows so well, I don't know why this would ever happen. And just take this and ship it straight to production, and then like a couple hours later, or maybe it kind of takes a little while, you realize just how wrong you were. But having a process in for ripping things out that are no longer providing fruit is good, because that's a waste of resources, potentially CPU. So from like red team perspective, what's my general thought process? So I'm going to kind of say this like first person a bit. Like as an adversary, first step is like I want to get to where your crown jewels are, probably. So how do I get there? And like, well, first things first, I need to get into your environment, and that's I don't have the stats. I should have. But like spear phishing is going to be like half the time. So like getting like I want to get some document, I want to get code to run there, and then the first thing is often as part of that gaining access is figuring out if you landed in the right place. If I have something, and if you're like a nation state and you don't want to burn all of your tools right away, and so there's going to be some level of like, am I running in a VM? Am I running in some honeypot or something? So figuring out that you are where you're supposed to be, and then persisting. So setting up like a task or something so you don't get wiped out the next time the system boots or the user logs off. And then from there's often a step of gaining interactive access. So now that this code is running, it's where it should be, it looks right, it's it's persisting, calling back so that I could take hands-on control. And unless you have something really sophisticated and a really expensive group, that there ends up being so much like research. If you want to script everything, that's a lot of money and a lot of research that sometimes you don't have time to do, and it's just easier to just like hand it off to an operator and let them figure out as they go. And then once you're having access, it's just a matter of moving closer to the target. So gaining privileges, gaining credentials in hopes that you can move across hosts, get things to execute. And then hopefully finally, once you get where you need, taking data if you want it, finding ways to get it, zip it up, get it out. Or if maybe you have a more malicious mindset than just like stealing data, maybe want to destroy someone's mission. It's like wiping a hard drive, or even like ransomware kind of falls into both of those. So like that's kind of like what the end goal was. And then all of this needs to happen while you're evading detections. So like I don't want to trip up your EDR or AV as a red team. And so MITRE took all these concepts, organized them to this framework called attack. It mostly goes, in this case, top to bottom, but over here it's like left to right. is there a framework? So tactics being those higher level goals organized into, the individual techniques, which are like the cells, organized into columns, which are the high level goals. So there's like hundreds of threat reports consolidated in here. If you just want to understand like what do threats look like in general, you could even go here and look at like credential dumping, and there's going to be a few dozen reports that are linked to that. It's like, okay, that's a pretty good technique that maybe I should prioritize. And one example of a technique, like the spear phishing one, there's going to be detail about how it works. Often, like if it's a Windows thing, what OS internals are relevant, how you can detect it, how you could potentially mitigate it and harden, like group policy. And then there's also metadata like what endpoint or what OS is it on, what data sources are useful for detecting it, and those specific examples. So the next thing is like we know the threat, we got an idea of that landscape, like what could we actually have to detect. So what does our data look like? I'm going to use some examples from Sysmon, but with the field names a little bit renamed to look like this. So this is just a general like process event, thinking like command lines, you got hashes of the process, the path, the user, just a little bit of metadata here. There's still plenty more, like looking at token identifiers. But this is just like at a quick glance what data ends up looking like. And for us, it's mostly pretty flat. So EQL ends up working on top of that data you have. Our hope is that it's supposed to be easy, simple to use, read almost like pseudocode, and it's independent of the schema you use. If you've got a different data set, you could just use it with that. You know your fields, you're good. And we've also have designed it for a few like real-time solutions. We use, like within our own product, we use it like both on our sensor and a few other places. So it's designed with like real time in mind. So if you have things that need to maintain state, it's like you can do that as well. And you can also support like multiple behaviors. So on like some solutions that might think like atomically, like can I find this hash, this path, this command line? Maybe have like a process that drops a file that then runs. Being able to represent that is really important. So we have the ability to express that. We also have like a function syntax. So instead of like having a million keywords everywhere, like contains, starts with, it's just we use functions for things. And can do like glob wildcard matching. So this is just like some of what those syntax looks like. More specifically, a query would be like look for the SVC host process that either doesn't have like -k in the command line or doesn't have a parent of services. And this would be a weird thing to see in general, and I'll get to more specifically why later. But that's just like simplest form what an equal query would look like. For a sequence, you can say that there's a time span. Maybe they have to share certain things in common, like a file path has to match the process path. And then you can also say when a sequence expires. So maybe you're tracking some behavior, but if there's like a log off event, you stop tracking that user. So being able to express that as well. So this is what that syntax would look like. One thing here that's noteworthy is that like within these brackets for the sequence, like this file where file name is like .exe, that ends up being one of those simple queries from like the previous slide. It makes its way into a sequence. You can also do joins. They're pretty similar, but it's like the order doesn't matter. So maybe I just say I need one file event that looks like this and a registry event that looks like that, and that's enough for you to kind of say like find these two things that need to happen but separately. Another thing you could do with joins is you could also like join certain properties together. So like 3 network connections that are incoming, like SMB, RPC, and RDP for all like incoming lateral movement methods that have to have like the source IP and dest IP together. We can also do pipes. It's the Unix-like pipes. So here would be like piping it through uniques, doing counts and filters to essentially give you like hopefully all the stacking questions you need to answer to say like give me the 5% rarest things, or give me the 5 least common process command line pairs. And lineage as well. So since we do have a lot of like endpoint specific use cases, and it's stateful, we can express like process lineage things. So being able to say, I want a network connection from PowerShell, unless that PowerShell came from Explorer.exe. So having like that being able to express in the syntax has been like super powerful for us. We use this a ton. And then you can also use like child of and descendant of, and you can nest them. So here, like we've got a file where it's an event of a process that was a child of. So like, I will not read that any more than that. But you can nest things as much as you need to. Kind of like, it might feel a little bit like a Splunk sub search if you have any Splunk experience. So that's kind of background. How do we actually take all of this and actually start finding threats? So like, what's our overall approach from that like white paper earlier? Now that we understand the general tactics, we got an idea of like what the adversary is trying to do, how they operate, going from coming in to coming out. What are the next techniques that they use, those individual cells within attack? And if we understand specific techniques and behaviors, we can craft a lot of detections for those techniques. And sometimes we do need to like dive into just a bit of Windows, and I'll do that, but not in depth. So I'm going to go through those kind of like top to bottom, getting in through all the way like making an impact. What's a particular technique, and then what's a detection that we could write for that. So one is looking for spear phishing attachments. So a lot of them are going to have embedded macros, and they're going to run. When those macros run, it runs in the context of that Office product, so like Word, Excel, PowerPoint. But then, if the script, often there's like, you need to leave Office to do the thing you did. Like, I need to run some software, I need to run something in PowerShell, because maybe the whole thing's not written in like VBA. Or maybe the PowerShell itself was like a stage 2 downloader. So being able to like say like, oh, if you have a parent of Office and the child is a scripting application, that shouldn't need to happen normally with a legitimate VBA. So this is one way that you could detect like a spear phishing. Another way would be maybe without looking for specific scripts, something dropping its own binary and then executing it. So like we can express that with the sequence of saying within 5 minutes, look for like a .exe file being created from Office. And then the whole like this by file path part, right here, this by file path matches a process path. So like like you'd have a where in SQL, but it's like always equality. So we'll always make sure the file path matches the process path. There's not like super advanced ways to compare them. So that's one example for like obtaining access. And the next thing would be like, how would you get your code to persist and survive? And also to run a system. So like if you're on a machine where you already have admin privileges but need system, one thing you could do is create a scheduled task. So I could create a task that then runs on boot up, or like user login, or some trigger event, or maybe at a certain time every day. But one interesting thing here is like you'll see, and I think from that report earlier, the Bad Rabbit one, or the Bad Wolf, it would first run as a user, but it would create a system level task. And so one thing you can like ask yourself, like, is this noteworthy? Is like, would a normal user ever need to create code to run a system? And like any scenario that I can think of is shady. So like, okay, that's actually not a bad idea. And we've had decent luck with this one. So it's just looking for the user that ran the command as system, but the user they try to run it as is, the user that ran it is not system, but the user they're trying to run as is. Another technique in attack, and this is where things start to get hairy, is looking at like command and control. So like if things were about like endpoint specific behaviors, how do you describe like a protocol choice or a way that like C2 is implemented? So one of the techniques in attack is looking for ports that are uncommon. And it turns out there's a lot of custom ports that are uncommon. This is not, I didn't even make it, there's like 443, and this is already like way too many. So I don't know how this would ever scale, and if you ever tried, like this is what this looks like. Just spoilers. And if you try that, you're going to have a bad time. So I wouldn't recommend that. A different approach might be easier is looking for like the living off the land binaries and scripts. And so thinking of for a given process, is it something that has like functionality to run other code inside of it? So like Windows has a ton of built-in tools like mshta, install util, msxsl is run DLL32. Like there's a ton of things that can do whatever code you want. And a lot of these really don't even have, when they're used the most legitimately, don't even have any need for making a network connection. So looking for, instead of thinking like, and if you're using like sysmon-like data at the endpoint, there's a good chance that the level of telemetry you have isn't internal to that connection. So you might not be able to reason about C2 anyway. So here, this is just like I think, perfect mix of visibility of looking at like process names and networks. Another thing about turning this into a sequence, instead of just saying like just a network from this process, is if you did have an alert for this after turning it into a sequence, you get both like the process and the network event back. So now I can reason about the command line and the like destination address and port at the same time. Another technique would be trying to blend in and stay stealthy. And one thing, like after, this would probably happen like along with persistence, so like persisting something in a strange location. One common technique is to use names of normal Windows files, but put them in slightly different folders. So like seeing a lsas.exe, which is like a built-in Windows process that should only ever run once, putting it inside of like C:program data would be just super weird. And then there was another one, I don't remember exactly, it shows up later, is C:windows system 32 INF, then SVC host. And so it was just off, but just slightly, but that's enough where like there's no SVC host legitimately there. So looking at things being in the wrong place ends up being super useful. Another one, and this is a little bit wordier, but the main idea here is looking for like parent-child process relationships. So there was this old blog post, it's like know your processes or die trying. It's related to like a SANS, like DFIR post, or poster. And essentially it's like when Windows boots up, here's like the boot up sequences, like system, SMSS, SMSS, WinInit, and it keeps going. But that's the only time those processes ever execute. So like if you see a WinInit process being spawned by something other than SMSS, that ends up being weird. Or looking for two LSSs running or one running with the wrong parent. So if you don't have like visibility into any injection or like memory-based techniques, you could use this to infer that like something weird is happening and this thing is still running. There must be other code inside of it. Yeah, and then one other thing is like the credential access. So you could go like the Mimikatz route and look for like access to the LSAS process. Another one that looks like, why is this the most trivial query so far for one of the most complicated behaviors? Because it sometimes actually works, and I don't know why. Like, it's like, oh, I think this was like, yes, this one was just like, oh, this would be funny. It's like, oh, sure, why not? You know, might as well have coverage for this in case it ever happens. And we find like red team's actually doing this, like, no kidding. All right, well, cool. And then now they won't anymore because that's out. Another one that's like really important for like attacker lifecycle is like maybe before laterally moving, figuring out what hosts I can move to, and figuring out what hosts are there and what accounts are there. So there's several different commands to discover that information, and you could look for all these happening in a sequence. You could do some really fancy stuff. There's like a analytic and like MITRE's cyber analytic repository looking for several of these happening within a short window of time. You could have a batch script that does like an ipconfig command 50 different times, and it just blows up the thing. So like a different approach that I had was, what if we just build them into buckets? So like, what if you have one bucket for like discovering like network or like host level telemetry, one thing for discovering like network, and one thing for discovering like processes that are running. And with the join, the thought is if there's one user running at least one of each of those commands, you then get an alert off of that. So that's like another approach to try to discover like suspicious recon commands and try to handle all the false positives that there are. Another one for like actually moving to the target host is thinking of like remote PowerShell. So like think enter PS session is the PowerShell command. So within like a short time frame, you're going to see like an incoming WinRM network connection followed by like the WSM provider host, which is what the remote PowerShell process is going to run under. So if you see those in like the same time span, you got like a pretty good chance at that window that they're related, unless you have a lot of WinRM going on. And there's enough info there to tell you like where it came from. So like since you have the network, you're like, oh, here's the source, here's the dest. I can tune out any admins if this is legitimate, tuning out like whatever host they normally use. Looking for collection and exfil. So a lot of actors will still, I think like WinRAR it's not open source, so they'll bring a copy of it, drop it with like a different name, and use that to encrypt like a RAR archive and take it back. So looking at like those command line flags followed by creation of like a RAR file from the same process would indicative that, like, okay, there's WinRAR happening. How often do people normally use, like, either maybe on a Windows machine to actually use the command line for it? Probably not very often. And I think this one actually, for the MITRE, like, APT3 evals last year, this was one of the ones, for one of the techniques that they did that ended up working out well. Another approach for looking for, like, those collection of critical information would be looking for keyloggers. So a lot of telemetry isn't going to have this. Like, you look at, because it's like API level. So if you do have any low level, it's just like kind of another use case for EQL if you've got the data. Looking for calls to, like, those Windows APIs that are known for keyloggers. So, like, there's set Windows hook X. There's a couple, like getty state and key state is another one, but looking for them called with certain params. In this case, it's that API being called with thread ID of 0, which means just hook everything. So that's one example for, like, what a keylogger would look like if you have API level data. And the final technique is through that life cycle. It's like, what about someone destroying information or cleaning up their tracks or destroying just any evidence? So looking for, like, deletion of, like, volume shadow copies. This is the inhibit system recovery technique. Looking at deletion of volume shadow copies through, like, a couple of known utilities, or looking at the Windows event utility for clearing event logs. Clearing event logs, it's funny because it's like event logs it'll create a new event called event logs were cleared, but then you don't know what the logs were before. So it's like, well, I guess that's kind of the point, but at least it tells you. So if you don't have, like, process level telemetry, you can also grab it from Windows event logs. So that's, like, these are just a handful of techniques that you can use in detections when you know what you're looking for, right? Like, all of those, like, it was a specific technique. So you kind of have to cross your fingers that, like, someone actually did the thing that you wrote the detection for. So the next question is, like, well, what about when someone does something that I didn't anticipate? Like, MITRE is, like, the attack framework has, like, 244 techniques now. And if this is recorded, I'm sure it'll be different by the time, like, it's, someone listens to it. And that's changed a lot over the past couple of releases. So even when you're thinking of just, like, adversary behaviors, those are still continuing to change, not nearly as fast as, like, tooling. So it's really useful to come up with ways to detect things even though you don't know what you're looking for. Right? Because you're thinking, like, okay, someday I'll know what it was that I was looking for today. If that made any sense at all. But whatever it is that you're trying to detect, someone will find it eventually and they'll write a report about it. But you don't have that report. You're still stuck in today. And so, like, the information you have is, I don't know why I did these animations, is so little, but, like, you still have in general the structure, right? Like, how does the red team think? How does an adversary think? What do they need to accomplish? And there's still things you can look for, different patterns. You can cross that against your environment. So, like, here I think I blacked out, like, everything but run remote command, like SMB, lateral movement, a couple of things are, like, definitely going to happen anyway. Yeah, so basically that's what this feels like, but it doesn't have to. One approach for this is to ask, this is where the memes kick in, so it's like, this is super dry, it's like, I'll try to not be as bad. So how do we proactively look for the adversary? And part of it is, like, thinking red. And then thinking, like, for each action in general, like, not thinking of the specific way they did it, but the general, like, what are their goals and what evidence would it probably leave if someone achieved that. And a lot of those are also useful to think, like, what, not just, like, what evidence would it lead, but also thinking of questions that are weird for your environment and how you can bake that logic into a query. And some core concepts are looking for, like, prevalence. So, like, is this on 3 endpoints or is this on 3,000 endpoints? Like, because if it's on most of your endpoints, it's probably going to be built into the gold image. If it happened more recently, that's also worth changing or worth tracking down. And then the final thing is, like, looking for patterns, like something running at the same time every day, or, like, beaconing out. Like, what is this that's new and it started happening every night at 9 p.m.? Like, what's that? One general, these are, like, heuristics, right? These ideas is looking for unusual parent-child relationships. Arrested Development for anyone. One thought for this one is, what if I have all process creation events and I connect like the parent and the child, like grab all those tuples and see which ones are recent. So like the tail 100 would be like, all right, we uniqued them, we deduplicated them, but like added the duplicates. We counted them. So unique count is essentially saying remove the uniques, but count how many there were. So essentially we've got all those parent process pairs. We know how many there were. We grab the 100 most recent of those, and then we grab it's like the 10 rarest of them. So like these are like things you could totally fuzz and play around with, but still it kind of gives you a sense of answering the both recent and rare at the same time. And there's some like sample data here. There's a mix of like good and bad in here. I don't know if anyone has any guess of what might be weird. But so like that actually brings up a good point. It's like instead of saying all parent-child relationships, like within this table, there's names that are completely random and determined at runtime. Like those will trigger because you've never seen it before. So by definition, it's going to be unusual as a pair because the first one's unusual. So one thought is, what if I said unusual parents of CMD? What never ran CMD before today? Or what never ran from PowerShell before today? Being able to throw like that heuristic in there, and now you've got things that are already like interesting to you, and they're anomalous. So it's just like, okay, how can we sift through our haystack a lot faster? Another example is looking for remote access tools. So if you're thinking like from the adversary, like I need to control this piece of software, and so if that's a new file, that'll be created on disk, and you'll see a process run, and then it'll make a network connection. So we have like what processes made network connections like ever, and then what are the ones that most recently did. It's just another way to look for that. And of here, you'll get a lot of like setup executables because there's like web downloaders, right? That they'll just it's like, oh, this setup.exe file is only like 1 meg, cool. And like you do, it's like, okay, downloading update, it's like 60 megs, it's like, all right. So that would definitely like FP here. But there's also this install util command, another built-in like Windows script that's like easy to abuse. So that's like another example. You'd find this making the network connection. Another idea is looking for more environment-like specifics of saying, what have I seen before? Like what processes normally run? I have them, but they don't normally make network connections, but now they did. It's like, why the sudden change in behavior? Like, why is Hide the Pain Herald talking on the phone? So this one, like looking for like MSI exec, that's going to happen like all the time because setup files being run. But looking for it making network connections, maybe in your environment you're shipping that out, maybe you're not, but you can at least like answer that question, is this weird for me? Another general behavior that's worth detecting is like persistence. And so this one is a little bit cheating, I guess, because this is watching keys that you already know. So looking at like a ton of registry keys that you know are used for persistence. And then just doing stacking on that, finding things that are rare, finding things that are recent. And then within here, there's again a mix of like some true and false positives, and like whenever like psexec is installed, it's gonna whenever it runs, it's gonna install a service if you run a system. So you'll see even like evidence of that show up. Another one is looking for processes that are files that are dropped to disk. This is like that earlier example from the spear phishing. A file that's created on disk by a non-system user, but then like within some short period of time it ran a system. And so it's like, how? Maybe it was abusing a legitimate service, or maybe it just repersisted itself as system without thinking about like where it was. So there, again, here's some examples, some like true and false positive. And this is another one, okay, cool, laser is working. This top one earlier, that's like would trigger our other analytic for looking at both parent-child relationships and for things running the same multiple, in a different location. So like this, one technique, we end up just detecting like 3 different ways. And there's also like false positives. I guess like Zoom, likes to run as a custom Zoom user and then, install things as a system. So that's one. Another one is looking for processes making recon. So if you're thinking like, again, from like the adversary perspective, like I've got code that's running my remote access tool, and I need to run commands to figure out like what I'm doing, where to go next. In general, you're thinking like that tool has to make network connections back. So that's where the and child of part of this is going. So there's an outgoing network connection for the process, and that process made a child command that's like a discovery, a potentially suspicious thing, like a who am I with a network connection. It's like, I kind of want to know about that. You could also flip this, and instead of saying like looking for outgoing network, looking for incoming network, and that could be useful for detecting potentially a popped web server, like looking for a web shell. Another one is looking for brute force attempts. So if you've got moving a bit from like the sysmon data set to Windows event logs. So Windows like 4624s. Oh shoot, I flipped those. Sorry. 4624s are success and 4625s are failures. So seeing like several failures in a row and then an eventual success. And with the until command, with that syntax we can say like if they ever do get a successful login in less than 4 attempts, reset the counter essentially. And so that's kind of one way to be able to like statefully track without accumulating like all of the logon failures they've ever had. Another one is looking for like WMI incoming. So this one we can dive into some Windows internals just for a bit. So like whenever there's incoming lateral movement to a host from WMI specifically, it'll create a new, and since it's lateral movement that's incoming, it has to create a new logon token for that user. But then the first thing that was used is to actually run a WMI command. And so here with this query is we've got the look at all process events, and then unique on the logon ID or the authentication ID, which just would grab the first one that ever happened. So now you know the first time a token was used, and you could say, was this used by WMI? Yes or no. And if it was, this might end up being useful. So like I've seen like Nessus, like false positive this, but then there's like this Lazarus group example with a fake IP of what they would use and what would be observable for this analytic. And then one last like heuristic, how to hunt for the known unknown, is looking for hosts where you've got incoming SMB connections. Yeah, spoiler, they don't make it. Incoming SMB and incoming RPC, so like a file being uploaded to a host and then some action being requested or performed on it. You don't even have to know that that's the file, but like kind of putting those two together is noteworthy. So like, especially on a workstation. And you can lock this down a lot with like setting up group policy and setting down firewalls. But if you don't have that, like, this is still like worth checking. And on a domain controller, this is not going to really work well because you're going to have a lot of incoming RPC that's legitimate and a lot of SMB that's legitimate. But that's kind of the nice thing about this is since like you're uniquing on source address, you get one, and you could even like add unique count or something. So looking at like those sources and sinks in your networks and figuring out what's unusual for you. So those are some general like strategies that I've always enjoyed doing, especially like lateral movement. I've always found to be noteworthy because then it's just like not just looking at one host, all of its history, but like host-to-host interactions. So what are we trying to do with EQL in general? Like what's the community we're trying to build? We want to like share several of our analytics, and if you want, like since it was open sourced, you could just it's written in Python, so you could just install it with pip. There's like a command line if you want to play around with sample data. You can test these queries out. There's like some blog posts that we have, and we've got this analytics library. I'll show you what that looks like in a sec. Where we've contributed so far 45 or so analytics between like us and a handful from like Red Canary, and have data sets if you want to like get your hands dirty. There's also scripts that we have if you do like sysmon and you want to get it from out of Windows event logs and then out of XML and then into like JSON. We have scripts for just like scraping Windows event logs and doing that. And just like this is all I can read the docs. One cool thing that I like is with like the attack framework, there's often so many ways to do a specific technique. Like, one of them here is like credential dumping is still its own technique. Like there's not memory-based credential dumping or stealing from LSAS. It's just credential dumping. So since there's so many different ways to do that, we can see like all the different detections we have for that. Instead of thinking of just like, do I color this red, yellow, or green? Kind of getting maybe a little bit better count and sense of what you have. We also have code in there for normalizing. So like, I don't expect everyone to use the field names that we do and that we thought made sense. So if you have a query that's in equal, like here, this example is looking for like the process where it's like a creation event and MSHTA, and it has like program data in the command line. But you can convert that query from our schema into like sysmon, and so that way like it's maybe more readable or tractable if you need to like manually convert it to another language or something else. You at least have the fields already there. And one thing that's kind of cool about this is we also have more like semantic-like conversion. So the process name doesn't exist as a field in sysmon, but we know that it's part of the path, right? It's like the name of the file of the full path. So if you say process name is MSHTA, because of that mapping, we can say, oh, this is based off of the path, it's *//mshta.exe. So we can normalize it in maybe interesting ways that are not necessarily trivial. And you can go the other way too. If you have data that maybe like you have your internal thing that's your format you want to kind of keep sensitive, you could map it from your format into like another schema. If you do want to like share that. So like reason for all of this is because if we do want to share things, it kind of needs to, and everything looks all different and chaotic. It's kind of hard if we're not speaking like the same language, or at least like the same fields even. So what's next for us for EQL is we over the next couple weeks. I was hoping for this week, but I'm thinking the next week or the week after that is early June. Having an update to that where we've done a lot of work internally for better like schema validation. So if I type in process paths or something, like, oh, okay, that's not the right field name. Did you mean process path? And so adding better error checking, and that way, like when you do like a function in equal, not just breaking, so like trying to turn it into a bit of a real language. And then there's also like a Python API, so if you ever do want to like incorporate this, you can just like import it straight into a project, run data through it, get data back out, and it's all like real-time streaming, so you could just like, whatever your queue is, as long as you can keep up, you could put it inside of something else. And then we've got a lot of, I'm not sure what the total number will end up being, but at least like 75 or so new analytics mapped to attack. So think of that. If we did go back and have this red and green, we would hope for a lot of at least yellows. Oh yeah, so if you want to get in touch, we do have a Twitter account and a Gitter, which is like a developer like chat. So kind of like Slack, but it's but you can already use your existing GitHub and Twitter accounts, so you already have access to it, and it's lurker friendly, so you don't have to like commit. You can just kind of watch and see what we're talking about. There's also an email if you want to go old school. There's no actual like post office box or mail, but email's an option. We've got lots of resources as well. I don't know if we have any books left, but there is like this PDF that you can get if you want to like download more of like what is threat hunting, how can I get started and take these principles, maybe like screw equal, I don't care about your data, I just want to know the hunting part. It's like, cool. There's a pretty good book and some blog posts on like how to hunt and how to contribute and how to share. Yeah, so that's all I have. Does anyone have any questions?
Can you go back to the slide?
Sure. Yeah. Pictures. Yes, of course. I'll leave that up while if anyone has any questions. Sure.
I was looking at Read the Docs, and there's a tiny sample file for getting started and using equal, but is there like a more substantial data file for people to use to get started with?
Yeah. Yes. Here. I wonder if I can do that. I was thinking ahead. Did not want notifications in the middle, outside of my fake one, of course. Yeah, so on our GitHub, we have several data sets. Some of these, the smaller ones, we just have like in raw JSON, so you can look at what these are. And then there are a lot of the other ones, the bigger ones, we've got like JSON gzip, so you can just pass it straight to equal as it is. It'll ungzip it, unJSON it. Any other questions? Yes? Sure.
How specific is this, and maybe it's really more of a schema thing, to endpoint stuff versus, say, network work?
Oh, sure. So I think, yeah, that's largely going to be a schema thing. You might find cases where maybe there is something that you want to do a really advanced, like stateful thing that the languages can't express. But as far as the data goes, whatever you give it, it can take. I think the only real like endpoint specific thing is the lineage tracking, but everything else should be agnostic. And there is, I think it's like holdmybeersecurity.com, I think that's his name, wrote a blog post on how he's using this with Bro, or Zeek, data sets. Sure.
Sorry, I was using equal while you were talking, so I apologize if I covered this.
I need to apologize for that.
Is there like a process name normalization in equal so that like slash or extra backslashes or other things like that are normalized so they're actual, or is it something that the author's going to have to do?
I think that would be something. There are ways we can like hook, if you have like more advanced normalization, you could hook it up. A lot of that part is actually not documented well. But I think a lot of that will come down mostly to whatever gave you the telemetry, like its data. So I guess I was kind of assuming that it gave you something that's like semantically similar to how we would look at it. But yeah, there's ways to extend that for those more advanced cases though. Cool. Any other takers? Right on.